I'm here to talk to you about the HPC experiment. We refer to our experiment as the UberCloud HPC Experiment. I'll talk about what it is. I'm not from Intel. Intel got a lot of mileage out of this picture, but they were the sponsor of our previous talk, and that's the last time Wolfgang and I were together. Wolfgang, for a few of you who might know him, works out of Germany, and I work out of Silicon Valley, so we don't get to see each other very often except on Skype, which isn't a great place to take photographs. So the idea of the UberCloud experiment, the HPC experiment, came to us about 9 months ago. Wolfgang and I were talking about why the HPC applications were not moving towards the cloud. So what is the cloud, right? So is it multi-tenant? Is it pay per service? Is it remotely accessible, etc.? You know all the tenets of a cloud application. What we were observing was that a lot of web-facing workloads were moving to the cloud. I mean, who would run a WordPress server anymore on their own desktop machine, right? Not anymore. All of that is in the cloud, but a lot of the high-performance computing applications are not necessarily following that model. So we started researching why, and people started throwing all kinds of questions. Well, how are you going to handle large files? How are you going to handle, privacy of data? How are you going to handle, intellectual property concerns? So we said, we don't know. We'll go research it. So we put out a request for proposal, and about 300 people signed up so far, and we are all experimenting together, trying to figure out how we can get high-performance computing on the cloud reliable. So when we talk about high-performance computing applications that we are primarily interested in as a part of this experiment, we are looking for industry-related workloads. There are already very good models for high-performance computing for academia. However, when you start looking into the industry, especially the small, medium enterprises, they really don't have a very good place to go and a good model to follow. There are lots of providers who would definitely sell you CPU power and very, very good services, but that's not really what the customer is looking for. They are really trying to get their problem solved. So all of that wraps under the HPC experiment. I'm not going to read all of this. And the barriers that I talked about are specifically the issues that we are going after, trying to find ways to work around them. And we do that with real-world examples. And I'll show you one of them at the end. The question that we are asking is, you have an end user who has a problem. He wants to figure out how to simulate, let's say, protein folding. Not that I could do that ever. But there are lots of barriers that he needs to cross. First of all, he needs to understand that, oh, okay, so I might have to do this remotely. Oh, okay, so I need to work with my software provider. They need to figure out how the licensing will work. Oh, so I found a remote resource provider. Now I need to figure out how to use their platform. And the questions go on and on and on before you can even start. So we started right about August timeframe last year. I was quite naive. I said, okay, so I'm based in Silicon Valley. I want to find end users who are right around here so I can gather them in a room. We can talk about this and start to solve the problem. Wolfgang knew better. He said, that's probably not going to work, but let's give it a try. And he was right. Our participants ended up to be global. We have participants from over 30 countries now. These are people who bring in their software, they bring in their hardware resources, they bring in their expertise, and they bring in their problems to the experiment for us to solve. We have already completed the first round of the experiment right around November timeframe, and we published our results, and we spoke at the Supercomputing Conference in Salt Lake City. That's where we were sponsored by Intel. And the second round is currently ongoing. We have about 30 teams actively working on real industry end user problems on remote HPC clusters. I'll skip everything about round one. A lot of these names may look familiar. Now, why is that slide even up there? It's not about to brag about it. The idea is for you to be able to run a successful high-performance computing application remotely, you really need a community of providers around you. You just cannot do it on your own. You will need people who will bring in their resource to the table and let you access it remotely. These people could be professional high-performance computing providers. They can be universities. If someone here is from Stanford University, I'd like to talk to them about how to get them on the HPC experiment as well. Some of them are geared, very, very much towards, applications in, computational fluid dynamics, or, they do have their own verticals. Some of them are very generic, and we do work with just about every one of these providers within the experiment. The other thing you need, obviously, is you need the software that can run in parallel computing environments. So this does get difficult, trying to figure out how to get the software providers to agree to participate in an experiment, which is free, right? Nobody's paying them for it. It does get difficult. However, we have a very large base of participants from the software industry, and they are really trying to figure out, believe me, they are really trying to figure out how to get their licensing models up to speed so that the whole HPC in the cloud can function. The other leg of the stool, so to speak, are the experts. High-performance computing is very difficult, and there are lots of challenges as you start going from starting from the deployment all the way to the visualization steps, all the way to the end. You will run into multiple issues as an end user. And most of the people that we deal with as end users are not necessarily savvy in solving those problems. So we bring in a number of participants who are in the business of providing their expertise in high-performance computing, in fluid dynamics, in biology, so that the end users can bring their problems in, solve them, and understand the results. So once you bring those parties together, the end user who has the problem, the software provider who's working with the end user, most probably already to solve the problem, the resource provider, and the expert, now you have the critical mass to approach the problem, right? Now, what we do within the experiment is, once we see an end user's problem, we do a matching. So we say, all right, so this problem requires this type of resource, requires this type of software, requires this type of expert. We club them together. And as the team makes progress, they do run into bottlenecks and issues, and we throw in extra resources to solve them. I'm going to show you how we do that in just a second. So these are teams with nicknames that we set up in round one of the HPC experiment. I put it up there so that you can see it's a very wide variety of projects that we are working on. So there were applications in anywhere from simulating water flow around a ship's hull, all the way to a site impact experiment in a auto manufacturing field. So we were warned, right? There are difficulties in high-performance computing when you try to do it remotely, and we did run into just about every one of them. The ones that we primarily ran into were related to how the experiment was set up, right? Everybody was doing it on a voluntary basis, so they didn't put all of their time into it. However, we ran into some very serious HPC problems as well. These are all listed in a publicly available document in our final report. If you send me an email, I'd be more than happy to get you a copy of that. Let's skip the hurdles. I am going to show you how this works, because you know all these hurdles already. There's no point. And in round 3 of our experiment, which is going to start in April, we are most likely going to have about 500 participants. That's the number we are currently trending towards. We already have about 350 participants today. And with every round, we get more and more professional. Our rounds are about 3 to 4 months in length. All right, so let me just show you very quickly. I talked about how we match the user and the expertise provider and the resource provider and the software provider together. Once they're matched, it doesn't mean they're in the same room, right? These people are going to be all over the world trying to do business together. So what we've done for them, every single box you see here, I know you can't probably read it, but every box here represents an active live project today participating in round 2. Every single one of them is an industry end user who threw their problem on the table and said, hey, I would love to solve this problem on a remote high-performance computing cluster of some sort. So we match them up with resource providers, with software providers, with expertise providers, and here's what we ended up with. Let's pull up one. Let's go there. So what we realize is, unless you bring these people together and guide them towards the solution, a step-by-step process, they are just going to look at each other in the face and not be able to do anything, right? So what we do for them is, once we bring the project team together, we give them a list of tasks. You're probably wondering what the tasks are. We give them a task list that we have developed and we continuously improve on. On this task list, there are about 25 line items, and we help the team go through every single one of them, define their problem, define the type of resources they need, define the expertise that's required, and start making progress on their problem together. We don't just give them a task list. That will not be very smart. We give them templates to fill out. So this specific team here, I'm going to fall over this cable at some point. Okay, so this specific team here, they are simulating a wind tunnel application to find the airflow around a bicycle and the rider, and I always picture it with a helmet. So they inputted what type of application they are going to run, what type of software, what kind of resource requirements they got, etc. And based on this documentation, we can continue to throw more resources at this team until they get to some level of success. Now, there is one important limitation on the experiment. We do not allow experiment teams to cross over 1,000 CPU core hours. 1,000 CPU core hours is probably not adequate to do anything, production level. However, it is good enough to find out what type of problems you run into and try to solve them. So it is real, but it is limited. That gives a lot of confidence to the participants who are providing their resources, providing their software, providing their expertise, that the end user is not there to just get free service. That is really not the goal of the experiment. We are not waving our hands saying, hey, free HPC over here. That's not the point. The point is, run into these problems, figure out what the solutions are, and move on to professional high-performance computing. Are there any questions?
Are you done?
No. I'll talk for a few more minutes. Okay.
I have a question, but
why don't you go ahead?
Now or later?
No, go ahead. Now it's fine.
Okay. First of all, I'm part of this, so I'm not from the street, so I know very intimately what's going on. But philosophical question. So it started, and it still is experiment. So in my humble opinion, experiment serves two things. One is to prove the concept, and second, when you're experimenting in school, is to learn.
Right.
So I think the concept is already proved. So it's doable. And so what is it? What was like on every round? What was the purpose of the experiment, and what is the latest
Okay.
purpose of experiment?
Excellent question. So the question is, what was the purpose of the first round, second round, and going forward, how is the purpose evolving? That's a great question. I get that a lot. So the purpose of the experiment is not changing from round to round. The purpose of the experiment is to figure out the roadblocks in preventing remote use of HPC by the industry and how to circumvent them so they can. Now, the purpose is not going to change from round 1 to round 2 to round 3. What is changing is we are getting much, much better at figuring out how to put the experiment together so that people don't run into problems that they don't need to run into. So we smooth out the capabilities of the experiment. However, that doesn't mean to say we are not offering things that are in addition to the experiment. So the experiment obviously is a learning place. But when people do learn, they need another place to go, right? They need something more professional. So one of the things we have already introduced is what we refer to as the UberCloud exhibit. Now, this is again paving the way for people to get from no remote HPC usage whatsoever to successful HPC usage on an ongoing basis on remote infrastructure. So the UberCloud exhibit is our methodology for letting people see what kind of solutions are out there. This is a paid advertising service by these vendors. Let's just pick one. For example, SGI. So what SGI is doing here is they are saying, hey, I'm throwing my hat into the ring. I am going to help people have HPC in remote infrastructures. I'm offering this service. What we add to that is we give the users the capability to join the experiment with SGI, so that somebody who's interested in learning more about them can join the experiment. They're already throwing their resources in for free, but that doesn't count for anything, right? Somebody still has to bring in the software provider, somebody still has to bring in the expertise providers, and we help them go through their use case and see how good the SGI offering is. Now, the UberCloud exhibit is not going to be the last thing that we offer. The experiment will continue to be free for first-time users who are trying to learn. However, we are also working with the providers who are a part of the experiment and telling them, okay, so let's just move the needle a little bit. So it was 1,000 CPU core hours for free. What if this was 5,000? So let's look for a discounted rate at that range. Again, it's probably not good enough for running a full production load, but it is a lot better than 1,000. So now let's get money involved and see what other problems we run into and try to circumvent them. So it's a step-by-step process, going from no usage to continuous professional usage of HPC in the cloud. Great question. Thanks, Greg. Are there any other questions at this time? So if you're a provider of any sort of HPC expertise, software that runs on HPC clusters, or you run an HPC center or a cloud initiative, one of the things that the experiment can provide to you is a methodology to show the end user community that you are really in this game. You're trying to really make this possible. So we're inviting all of you to participate in the HPC experiment. There are already success stories where a team of, let's say, a resource provider and an end user who met through the experiment are now continuing in their professional offerings, and it gives the providers a great way to introduce their services to the community and look for leads out of that. If you know end users who are in trouble, they don't really understand, they don't know where to start, they may know the software that they want to use, but they may not know where to go to get resources. They may not know how to even install this software. We can be of great help. And the other thing that we provide back to the community is you do not have to be an active participant. Probably all of you in this room could become a part of the HPC experiment just to see what kind of use cases we work with. We published a 70-page report on round one. The second round will probably even be more detailed. And we love to go through the challenges, the roadblocks, and the solutions that we have found so that the community can benefit from it.
Is it publicly open for everybody or just only for participants?
So the experiment is open to everyone. However, the report is open only to the participants. There's an executive summary, which is 2 pages in length, that I can send to anyone who's interested. And if the executive summary looks interesting to you, you might want to join the community and get the full report. Any other questions? Yes?
I'm sorry, I may have missed this. Came in late. Is this open largely to universities, academic environments, or is this something that might be available to startups, corporations?
Great question. So the question is the experiment open to academic institutions, or is it mostly for industry or private parties? So on the end user front, the type of problems that we want to concentrate on are the problems which the industry faces. So academia already has established methods of accessing high-performance computing. There's no need to create another parallel one. However, the industry does not have that today. So they run to public clouds, which are probably not suitable for them, right? They go to general purpose clouds and try to solve their high-performance computing problems, and they run into all sorts of issues. Those type of environments are usually virtualized, the network speeds may not be up to what they need, etc. And a gamut of problems arise. However, we can help them run on a purpose-built high-performance computing environment, which would be quite different in terms of the experience they get out of that. Great question.
What do your participating companies provide in the infrastructure? It's like SGI. What do they get out of that? Are they paying to be part of this? Are they just displaying their capabilities?
Great question. So the question is, what are the resource providers getting out of this experiment? Why would they even join? Are they paying to join? And what are they getting out of it? So what the resource providers get is, number one, they get to showcase their abilities. That is important. It's not easy for, now there are many resource providers out there, it's not easy for them to go find the use cases that really make sense for them. And they all have their sweet spots. Not all HPC environments are built alike. So what we find is, once we bring a healthy load of projects in, and we ask our providers, hey, what type of projects are you interested in? It really helps them kind of pick and choose the ones they would be interested in. We never go to a resource provider and say, here's your project, go do it. The approach is, hey, we just found one. We think it would be a good match based on your profile. And if they choose to participate in that team, they run with it. And there are no hard feelings if they decide not to go. And we do not tell the end users which provider was the first or second or third choice. We just tell them which one got accepted at the end. So there's no losing.
It's the first HPC matchmaker in the history.
Yeah, I think I can use that as a tagline. Any other questions?